A single tree is easy to read but easy to fool. Nudge the data and its splits jump around. The fix is to stop relying on one tree and start combining many. A single tree is unstable. Ensembles cure this by training many trees and pooling their answers. Stratum offers two classics, both pure Swift. We'll predict which of three cultivars each wine came from. First, the random forest. It builds its trees in parallel and makes each one different, each trained on a random sample of rows, each split choosing from a random subset of variables. This is called bagging. Because the trees disagree in different ways, their errors cancel out when you average the votes. Bagging gives you a bonus. Each tree skips about a third of the rows, so every row has trees that never saw it. Stratum tests each row against exactly those trees and reports the out-of-bag error. Honest validation with no separate split. Watch it fall as trees are added, then flatten. Boosted trees take the opposite tack. They grow sequentially, each new tree trained to fix the errors made so far. The trees are tiny and added one at a time, each nudging the predictions closer. Boosting often beats a forest, but it needs more careful tuning. The convergence curve shows it. Error drops steeply, then levels off. The sweet spot is where it flattens. You give up the single readable flowchart, but you keep feature importance. Averaged across every tree, far steadier than one tree alone. As a rule of thumb, reach for a forest first, move to boosting to wring out the last bit of accuracy. Both trade interpretability for power. That's the whole modeling ladder. In the finale, we ask a different question. Can Stratum stay fast with 5 million rows?